AP Stats. This is Miss Rich with our video for summer work on data analysis. Here we have data on the number of goals scored by the U.S. women's soccer team in 34 games in the 2004 season. Listed here are the goals. You'll have a problem similar to this to answer questions on your own later. So what do these data tell us about the performance of the U.S. women's team in 2004? So it's important to know, as our first step in statistics, how we analyze data so it's effective. So we're going to first plot it. We usually try to make some type of graph, like here a histogram or a dot plot would be most effective. Since there's not a lot of data, we will put it on a dot plot, and I get this. So notice on my dot plot I've scaled and labeled what we're talking about. Make sure you always do that. A dot plot of the data. Each dot represents the goals scored in a single game, and from this graph we can see that the team scored between 0 and 8 goals per game. Most of the time they scored between 1 and 5, and their most frequent number of goals, the mode was 1 and the mean was 3.059, which is the average. So when you look at a graph like this, there are 4 things that you need to make sure that you always address when describing the data. First thing is the shape. This graph is skewed to the right. Skewed to the right means that the tail is going off to the right with most of the data over to the left. So make sure the skew is going in the direction of the tail. I'll just draw that quickly. Skewed to the right. Other possible measures of shape might be mounded, symmetric. Even if it's not exactly symmetric, you might say it's somewhat symmetric. Of course, skewed to the left. And uniform, where everything is about the same height, are probably the most popular ways to describe shape. But it's important to describe shape so you have a general idea of what the data looks like. Secondly, are there any outliers? Meaning, are there any really high or really low, out of the ordinary pieces of data? Now here, on the low end we have 0, and there's only one of those, and on the high end we have 6, 7, and 8, but I would not really call those outliers. And whether or not something is an outlier is really a judgment call. If we all of a sudden had one out here by itself at 10 or even higher, I would definitely call that an outlier. But like I said, it is a judgment call. You could mention 8 as an outlier if you wanted to, but since it's still right in line with the rest of the data, I would probably not consider it one. Next, the center. The center of the data can just be kind of an eyeball look at where the data is centered around, which seems to be around 3 here. It can be the mode, the number that occurs the most, which is 1. It could be the mean, which is 3.059 if we add these all up and divide by 34. Another very effective measure of center is the median, which is the middle number, which I would guess would be somewhere in the 2-3 range here. But just if you only describe center, that the goal scored was around 3, and you haven't talked about how spread out the data, that could mean a lot of things. That can mean every goal, every game, they scored 3 goals. It could mean they scored no goals a lot of times and they scored 6 or 7 goals a lot of times. So it's important that you also mention what the spread is. Now the easiest way to talk about spread is the range. The range here goes from 0 to 8, but it should be mentioned as one number, as 8, the difference in the high and the low. This isn't the best way to do spread. It would be better to talk about the standard deviation, which we'll study in class. On average, how far out is the data spread from the mean? Or the middle 50%, the length of that middle 50%. How far is it from the lowest quartile to the highest quartile? How spread out is the middle 50%? We call this our SOCs. S, shape, O, outliers, center, and spread. So whenever you're talking about a graph, make sure you describe the SOCs. Don't forget to put everything in context. make sure you're talking about the U.S. women's soccer team in 2004 and their goals as you're describing these 4 things. Okay, here I want to look, a lot of times we want to compare 2 groups and the data we receive about them. Here we have Alaska Airlines and America West Airlines, and we're trying to compare whether or not which airline seems to have more on-time flights. We can see from this data, Alaska Airlines has 3,274 as opposed to 501 delayed. American West has 6,438 compared to 787 delayed. And we turn those into proportions. Alaska Airlines definitely has more delays than America West. So America West you would consider would be the better as far as being on time. However, a lot of times there might be another variable we're not looking at. We call these lurking variables, a variable that might shed some light on why one is higher than the other. So here I've added in where the departure cities are for each of these airlines. And again, we took the same data, the number of flights on time, the number of flights delayed, the number on time, the number delayed for both airlines. And in the list, it's kind of hard to tell what's going on, but notice if we look at the proportion of just Alaska Airlines versus America West in one city, for instance, this first one is Los Angeles. The number of delays for Alaska Airlines versus America West just in Los Angeles, America West is much higher rate of delays. And here, if we look at Phoenix, 5.2% delayed for Alaska Airlines and 7.9% delayed for America West. So why is it that this data seems to be backwards when we divide it into cities? In fact, if we look at all the cities and we plot it on a bar graph comparing the percents of delayed flights for the 2, the green is America West, the blue is Alaska Airlines. Now remember, before, Alaska Airlines seemed to have more delays, but here you can see for each city that America West individually. The reason this is happening is because of, when you look at Phoenix, sunny Phoenix, which does not have a very high percentage of delays, look how many more times America West goes to Phoenix as opposed to Alaska Airlines. So this is skewing the data to make it look like America West has fewer delays when actually when you divide it up they have more delays. So we need to make sure when we're comparing 2 things that we really take outside variables into consideration. Thank you.